Welcome to the webinar, How to Build Your Business Case for Embedded Analytics. Just a quick introduction. My name is John Burr. I'm the General Manager of Yellowfin BI. And yes, that's a picture of me with much shorter hair and much better dress, but that was pre-COVID, so times have changed here. I let my hair grow out a little bit more. But Yellowfin BI is an embedded analytics and business intelligence platform that is part of the Idera technology portfolio of brands. Idera owns around 30 different software and technology companies. You may be familiar with some of the logos on there, from Fusion Charts to FileStack to UltraEdit. So really part of a larger family of developer tools, database tools, and DevOps tools. But today we are here to talk about making your business case for embedded analytics. Just a brief preview of what we'll talk about today. So first, data-driven mandates. So we know that companies are mandating more data-driven decision-making. That is what we've seen over the past number of years with many companies, and no surprise to us here. But how do you really take that data-driven mandate and create value from it? So whether that's improving internal operations or delivering more value to your end users and customers, what is the actual process of executing on that, if you will? Because it's one thing to have an idea of creating value from data, but execution is key. And then finally, how do we calculate the ROI of an embedded analytics use case, using data within embedded analytics to deliver value to customers and enterprises? What are some of the numbers around that? So we have a real life example that we'll walk through at the end of this presentation. So we are in the midst of the fourth industrial revolution. So like it or not, that's where we are. We're in the industry 4.0. And just a brief history lesson here. In the late 1700s, people started to say, "Oh, I'm tired of doing things by hand. Let's bring in some machines to do it for me." And that's what they did. So around 1760 or so, the advent of steam engines and textile manufacturing really helped to move the economy from more of a manual labor economy to mechanized labor. So cities began to crop up, economies began to explode, entire economies were built around this industrial revolution, the first industrial revolution. And this was really a revolution of mass producing goods for consumption. But in the late 1800s, Industry 2.0, or the second industrial revolution, was marked by the advent of electricity and telephones and telegraphs. And this was really around communication systems connecting people. And where the first industrial revolution was about using machines, the second industrial revolution was about speed of communication, speed of production, using electricity to power machinery to make assembly lines that can roll goods off of the production line and improve a business's output. Speed of travel, the internal combustion engine and automobiles really were brought in to fruition in the second industrial revolution. But then in, say, the late 1960s, early 1970s, we had the digital revolution, Industry 3.0. And this is really the revolution of computers and the internet. So this is where the world economy moved from snail mail to email, and from, say, printed encyclopedias to online Wikipedias. This was a revolution of information, if you will. We had global information was at our fingertips. It still is today. And this enabled us to start to work remotely, to buy things online, to access information from anywhere. So where the first industrial revolution was about machines, Industry 2.0 about electricity and speed, 3.0 is more around internet and information. But that brings us to where we are today in the fourth industrial revolution, which is what some are calling the cyber physical revolution. And that's really the convergence of digital and physical systems. For example, virtual reality, augmented reality, AI and machine learning, cloud computing, robotics, automation, IoT, all of it. It's about connecting and interacting between the physical and digital systems to really enable a better user experience or to help with faster human decision making. And I recently was just the other day buying a new refrigerator and doing a lot of research on fridges. And I noticed how many fridges have displays on the front, touchscreen displays, or connect to Wi-Fi and the internet, or even have cameras inside. So when you're at the grocery store, you can log in to your phone and view what's in your fridge and see if you actually do need more milk. But all this is to say that this is all powered by data at the end of the day. So data is a secret ingredient of the fourth industrial revolution. It's the fuel for this revolution. None of these things would be possible without collecting and consuming data. So at the end of the day, data is powering the AI algorithms, the ChatGPT that everyone is fascinated about today. It helps to provide insights and inform decisions. The data helps drive personalized marketing or innovations in healthcare that can detect diseases before you even know that you're sick. So really, the fourth industrial revolution is a revolution of data. And Mark Andreessen said a number of years ago, data is eating the world. And I truly think it is. Data is everywhere. It's just astounding. We're generating an enormous amount of data in this fourth industrial revolution. And you think about it, every time you surf the web, you send a text message, you shop online, data is being created. And not only is data being created, but it is also being consumed by businesses. So businesses are using this data to turbocharge their strategies. And this is not only sales and marketing strategies, but also internal operations. So things like targeted advertising is being driven by data, or even just identifying bottlenecks in a production process. That is all driven by this enormous amount of data that businesses are collecting and consuming. So that's to say data is being used across multiple functions of the business, not just one function, but and there's a lot of data. There's a ton of data. This is a very interesting graph here, but data is growing every day. If you look at this graph, by 2025, it's forecasted that there will be almost 200 zettabytes of data generated annually. And to put that in context, a zettabyte is 1 followed by 21 zeros of bytes. And it's astounding. And we're creating around 329 terabytes of data each day, which to me is mind-boggling when you think about how much data that we're all generating each day. I was thinking about how much data I generated today just this morning. So I woke up and I checked my sleep data. So I wear a smart ring. I checked the sleep data from my smart ring, and I walked downstairs to the kitchen. And as I was walking down, my smartwatch was counting my steps, collecting data on me. I made a coffee, then opened my fridge, which is now a smart fridge, to get some milk for my coffee. And of course, even the simple act of opening the fridge, generating data, sent to my phone, and I got an alert that my fridge was open and I shouldn't forget to close it. So I wonder how many megabytes or kilobytes of data that I generated all before my first cup of coffee. And so you think about, you extrapolate that to 8 billion people across the world, and it's not hard to fathom that 329 terabytes of data are generated each day by everyone in the world. And generating this data is one thing, but actually using this data and creating value from this data is a whole nother problem. A recent study by McKinsey found that only 24% of companies claim to have forged a data culture. So 1 in 4 companies are actually able to use that data in a data culture. And a data culture, the way McKinsey defines it, is an environment where data is valued, utilized, and embedded into the decision-making processes and everyday operations of the company. So we're generating almost 330 terabytes of data a day, but only 1 in 4 companies is actually using that data within their business, in their data culture. So it's clear that businesses recognize the importance of data, but there are often struggles to integrate that data into the organization's DNA. And this lack of forging a data culture can and does harm businesses or holds back innovation in businesses. And we see that, especially in the fourth industrial revolution, as tools like AI are mandating that you need to move fast with your ability to deal with data and operationalize it and make decisions on it. This is a really interesting graph about 3 different data companies that I'm sure you're familiar with. Spotify, which was founded in 2006, took about 150 days, about half a year, to reach a million users, which is in itself incredible. But you can see Instagram took half that time. Instagram, which was founded 4 years after Spotify, only took 75 days to reach 1 million users. And ChatGPT, which is powered by AI, only took 5 days to reach 1 million users. So this is just an example of how quickly businesses need to adapt to a data culture and use data in their decision-making processes. And it's not just these data companies. I would argue that all businesses should forge a data culture. It's imperative in this fourth industrial revolution, in this data revolution, to utilize that data in your business processes, in your decision making. But it's not easy for a lot of businesses. So we see across industries that there are a lot of barriers to adapting a data culture. These are just 5 examples from what we've heard when talking with our own Yellowfin customers. But one of the big reasons why it's difficult to adapt a data culture is organization of data. A lot of companies have a sea of data, a sea of information, no coherent data structure, maybe disparate data sources, data across organization silos, and it's very difficult to make sense of that. And even if the data was organized, discovery and analytic skills are lacking in organizations. So making sense of this data that's already not in a coherent data structure could require some advanced analytic skills, some data scientist skills. And it just interestingly, many universities didn't even offer a degree in data science until the late 2010s. So just recently. So if we're not even able to hire folks with that type of expertise, how are we supposed to make sense of this data? There's also a crunch for time and resources. So we know that with businesses, there's relentless pressure to meet deadlines and optimize resource allocation within the business. So oftentimes developing and implementing a type of robust, we'll call it a robust data strategy, could take a backseat to some of these other types of initiatives that have more of what we'll say a more immediate business impact, more immediate ROI. But that's why we're here talking today. How do we really show the business case for embedded analytics in a data culture? There's also a scarcity of data experts. We talked a bit about the data science degree, but there's also a shortage of experts in the workforce. But not only is there a shortage, it takes a long time to ramp someone up to the specific data within your organization. So it's not just a matter of having a data expert, it's having an expert of your organization's data and making sense of your sea of information. And finally, traditional solutions are not flexible. So many organizations rely on legacy systems that are often rigid and don't really adapt to changing data requirements, or even just the vast amount of data that is being collected, as we saw earlier. So this lack of flexibility can sometimes stifle innovation and can really inhibit the development of a data-driven culture. But none of these barriers are really insurmountable. So it just simply requires a new way of thinking. And this is, how do we move from a reality where we have a sea of data across silos in the organization? And again, this oftentimes is unstructured data. This requires data analysts to spend time making sense of, time that often organizations cannot necessarily invest in, given there's other business priorities. And how do we move quickly with this? Because as we saw in that example with ChatGPT, it could take you only 5 days to reach 1 million users. So how do we address these barriers? And the answer is really just engaging all users of the organization, just new thinking, not just creating a model around data analysts, but really a model around all business users who want to analyze and consume data. And that's really a principle that Yellowfin was founded on 20 years ago. We designed Yellowfin to really cater to 3 levels of users. That's the advanced data analyst or data scientist, the intermediate analyst, as well as just we'll call them beginner or business users who just want to consume data, want to consume the reports. So this new way of thinking is really where embedded analytics comes into play. So embedded analytics is the integration of the analytic capabilities directly into business applications. So if you think about a normal workflow of a business user, able to access analytical insights, dashboards, visualizations within their everyday workflow, and not have to switch to a different BI or analytical platform. So all of these reports are just built in to the everyday workflow of the application for both internal users and external users as well. So embedded analytics can provide value to internal and external users. External users would be customers in this case. For example, we recently did an implementation for a manufacturing company that embedded real-time dashboards into their current operational dashboard. So they were able to see just operational processes and where bottlenecks were and how they could really streamline that and remove some of those bottlenecks. But we also have cases where we've done customer-facing embedded analytics. For example, think about a financial services company that is looking to show customers their investment portfolios or market trends or risk assessments all within their online account, their online dashboard. That is an embedded analytics use case that we were able to help a company with and provide more value to their end users. So that is how we think about embedded analytics and forging a data-driven culture. It's using analytics to cater to the end user, whether it's business user or customer, within the context of the application. So how do you actually build a business case for embedded analytics? So we've talked with a lot of customers over the past 20 years, as you can imagine, and we have 5 main value drivers that come up all the time as customers are evaluating the business case for embedded analytics. So we'll dive into each of these, but just a preview, we hear UX, UI monetization all the time, improving the user experience. Data monetization. As we saw before, vast amount of data being collected. How do companies monetize this data? How do they build a business case around that? Legacy tool replacement. A lot of businesses were built with the tools that were available at the time, software available at the time. What's the business case around replacing that tool with a more modern embedded analytics tool like Yellowfin or other BI tools? How can a business reduce risk? What's the business case for embedded analytics to help them reduce risk? And this is especially important for financial services and healthcare clients that we have. And finally, how can embedded analytics impact the top or bottom line? So first value creation driver that we hear a lot is UX modernization. So there are many reasons why companies would want to do this. It could be brand perception and image. Maybe the user experience that a customer currently has, it looks a little bit outdated and they want it to look new and fresh. And by adding some embedded analytics capabilities, that will help to modernize the experience for their customers. Maybe it's something like evolution in UX best practices. And these applications are not as intuitive as they used to be because, as we know, user experience expectations change and there's new best practices. And maybe a platform like Yellowfin can help to improve that functionality. Or it could be something like user satisfaction. There's feedback from customers that platform doesn't perform as well or doesn't feel as modern as other platforms in the competition. Or maybe the company feels that by improving the user experience, that'll lead to increased user adoption. These are all valid reasons, but it's very, very difficult to create a business case around this because how do you attribute direct metrics to these types of reasons for using embedded analytics? I mean, you could look at incremental sales, conversion, or engagement, but it's almost a dotted line from those KPIs to your business case for embedded analytics. So not quite as easy. You can do it, but we have seen that it is difficult to make a business case around this. But we have seen a number of customers that are looking to monetize their data. And this could be in the form of new functionality. So you think about an e-commerce company, for example, that collects all this data around your purchasing habits, your browsing history, and maybe it starts to release new functionality that has personalized recommendations for products you could purchase. That's easy to create a business case around because you can measure results of that new functionality based on how many people make a purchase using that new functionality. Or a new module, for example. We worked with a credit card company that introduced a fraud detection module using embedded analytics. So this was a fraud detection module that would flag potentially fraudulent transactions in real time, just based on purchasing history, based on data it was collecting about the customer and other customers in the space. And this was a new module that could be offered to customers at a premium price. So the KPI there is identifying what the revenue impact is of the new module of people purchasing that new fraud detection module. Or it could be something entirely different, a new business. So for example, imagine a company that specializes in collecting GPS and location-based data from various sources. Maybe GPS devices, or I'm wearing a smartwatch, probably my smartwatch as well is tracking my location. This company could recognize the value of this data and monetize it, selling it to businesses looking to leverage location intelligence for targeted marketing, urban planning, or transportation optimization, for example. Or my smart fridge could be selling my data about milk to a dairy company, and now I start getting ads for milk or maybe plant-based milk alternatives. And it's easy to measure the results of that because you can measure how much impact to the top line that new business is bringing in and build a business case around embedded analytics there. In terms of legacy tool replacement as a value creation driver. So we know that legacy software and technology is abundant. I mean, that's just a fact. It's what businesses were built on the software that was available at the time. And often what we've seen is tools like TIBCO, IBM, or SAP can be 3 times as expensive, 3 times more expensive than newer tools, like, well, newer tools like Tableau or Yellowfin BI or other competitors in the space. But even looking at Tableau as an alternative, costs there can be really high if left unchecked. And we have seen cases where there are tools that base their pricing structure off of data consumed. And if you think about it, enterprises are continuing to increase the amount of data that they're collecting and analyzing. So that cost is just going to increase, could be exponentially, if that is the cost structure or the pricing structure of their agreement. But there is a business case to really replace some of these legacy tools with more modern tools. And not only could it decrease the cost by up to a third, but it adds more enterprise functionality than what was available in legacy tools. So, for example, there on the slide, there's an example of a feature we call signals that allows companies to receive an alert when there's an outlier in their data. For example, that example shows how there's a spike in sales data for that store type on that day. And that sends an alert to the stakeholders that are interested in that data. So those are just some of the cool features that new BI and embedded analytics tools can provide to enterprises. And I know Tableau recently announced, last month they have something very similar called Tableau Pulse, which it's a feature very similar to Signals, something that a lot of our customers love. But we do know with a lot of these tools, there's a lot of differentiating features. I'll just talk a bit about these 2 features we provide at Yellowfin, but we have something called guided NLQ, which is, that in itself is a reason to upgrade from a legacy tool to a more modern embedded analytics tool. So guided NLQ is a feature within the platform that allows business users to interact with data using natural language queries and get instant results of visualizations. And this is, for example, you can say, show me sales by region for the past quarter, or what are the top selling products in the last month? And the system will translate this into queries that provides, not just spits out a table of results, but really visualizations, charts, graphs, reports, and make it visually appealing for the business user. Stories is another feature that we have that allows users to create and share more narrative type presentations of their data, and combining visualizations and explanations and charts and graphs. So these are just 2 types of features that we offer, and there are lots of competitors in the space that also have differentiating features, but these are just reasons why not replacing a legacy tool is not just for a cost consideration, but also to add groundbreaking features and create value for the end user and for the enterprise. Another value creation driver that we hear a lot is using embedded analytics to reduce risk. And again, this is something we hear a lot in financial services and healthcare. But embedded analytics can provide real-time monitoring, for example, to help monitor risk factors within the context of the day-to-day operational systems of the stakeholders in the business. Or something like predictive analytics, being able to forecast and anticipate potential risks based on historical data, and enabling folks in the business to mitigate that risk and take an action proactively and not just reactively. Or even something like compliance and regulatory monitoring. So monitoring data in real time for compliance and ensuring that it adheres to standards of the industry, and doing this within the application experience itself. So people do not need to flip between different applications, but they can ensure that the processes they're following, their data is compliant with whatever regulations or standards they have in their industry. So in addition to reducing risk, one of the main value drivers we hear all the time is using embedded analytics to impact the top or bottom line of the business. So in this example here, this closely resembles a real case study not too long ago, but we changed the numbers a little bit, but it's directionally in line with the actual customer. This customer wanted to build a new analytics module to add to their core offering. So we talked a little bit before around using data monetization for new features, new businesses, new modules. This customer was looking to introduce a new module. And they thought that this new module would be adopted by some portion of their existing customer base. So we see the number there, customer base adoption percentage. They estimated in the first year, 15% of their existing customer base would adopt this new module, 30% in year 2, 45% in year 3. And they also thought that another outcome of this new module would be to attract new customers, because based on the market research they did, they saw there was demand for this module from customers, from prospective customers that they currently did not have. So they thought their growth rate there would be 5% of additional new customers that they would get as a result of this new module first year, 10% year 2, 15 year 3. And just to keep the math consistent and somewhat conservative, they estimated that the average selling price, ASP, for this new module will be $5,000 a year. So based on that, within the first year, 15% customer adoption rate, 75 customers, plus a 5% additional customer growth rate, 25. It's 100 customers purchasing this new analytics, or this new embedded analytics module. That would lead to revenue impact of $500,000. And year 2, $1 million, year 3, $1.7 million, which is significant for a business that was doing $10 million a year at the time. But it's not just building the business case. The reason why this company was successful in their implementation is they were really committed to tracking and being accountable for these numbers. Because it's one thing to offer the new module, but there's all this execution work that comes along with that. There's go-to-market strategy, there's advertising, marketing, there's supporting it. So it's not just creating a business case, it's also executing on that business case. So what does it take? What does it take to really make this work? And the answer is execution. At the end of the day, execution is arguably the most important aspect of any project. And embedded analytics projects are no different. But I will say embedded analytics projects are generally cheaper and always faster than traditional projects. We've seen analytics projects, embedded analytics projects that could be up to 5 times faster, especially if you're able to build and release a module within a matter of 3 months. Some software projects can take years, but being able to get to market within the first year is key to making this worth this, is key to executing on this. But there are a lot of considerations. There are a lot of considerations for embedded analytics projects, just like with any project. The good news is that most of these factors are not very different than regular projects. You have to manage the costs of the project. Software licensing, implementation costs, internal and external support costs, all of those are important, not just for embedded projects, but for traditional projects as well. But there are two aspects highlighted in blue here that are a little bit more unique for embedded, and that is hosting, SaaS versus on-prem, and also value-based pricing. So hosting, which arguably is applicable for other software use cases, is hugely important to consider as part of your embedded business case, as well as value-based pricing. So value-based pricing, which has been a buzzword for a long time, is even more important here, especially if you're using embedded analytics as an end product for your own customer. And so we'll dive into each of these in a little bit more detail here. Hosting. So hosting, really, this approach depends a lot on your preferences. Well, not preferences, well, internal capabilities is a better word. So whether you go SaaS or self-hosted, it's up to what your organization is comfortable with, where your organization has capabilities. We have some customers that do not manage anything internally. Everything is a service, it's a managed service or SaaS. So for those use cases, it makes sense to pursue a SaaS offering. But we know that self-hosting is generally cheaper, because with a SaaS offering, you are paying a third-party vendor to manage your service and not managing it internally. But on the flip side, we see that SaaS-hosted offerings typically are faster because it's easier to implement and a much simpler experience because it's all standardized and managed by a team that is already an expert in that platform. So the reality is most BI vendors are not simple solutions. And some actually try to hide how complex they are by only offering a SaaS solution. But there are a number of BI vendors that offer both, and Yellowfin is one of them. We offer both SaaS offering and self-hosted offering. But the reality is a lot of BI is complex, especially if you're looking to support, say, 100,000 customers at scale. There's going to be a little bit of complexity there. But whether you go with SaaS or self-hosted, that's really up to you, and that's what your organization is comfortable with and based on your internal capabilities. In terms of the value-based pricing structure, so this is, well, I'll say this slide's probably a little bit too complicated for the point we're trying to make here, but this is an illustration from that same software company we talked about before that introduced a new module. So with that new module, a traditional pricing would be they would pay to license the embedded analytics software for that module at a fixed rate of $275,000 per year. And that's a flat fee based on the maximum number of organizations of 300 or so. As you can see here, we also built a value-based structure that's scaled as new organizations began using the module. So this is a cost based on the value that that our customer perceived from the product. So you can see the cost in year one was much lower than in year three because there were fewer organizations that adopted that module. So it kept costs in control. And this also helps to ensure that our KPIs and costs are aligned with their KPIs and goals, that as they add more customers, only then do their costs increase. So traditional pricing, the customer would have spent $275,000 a year for yearly subscriptions. Likely year four, they would have more than 300 organizations, just given the growth rate there, and need to renegotiate that contract. But value-based pricing is more scalable and allows the company to really forecast their costs as they know their growth rate changes. So this is really an ideal pricing model for ISV and embedded pricing. So I encourage you, as you're looking to make your business case for embedded analytics, look into value-based pricing models and try to align your priorities with the priorities of your analytics vendor through this type of pricing module. So finally, the bottom line. So this is the same example as that software vendor, as you can see here. Revenue impact, $500,000 year one, 1 million year two, 1.7 year three. But how does that really impact the bottom line? In this example, with the value-based pricing, first year costs were around $117,000. If they had used a traditional pricing model, that would be $275,000. So almost $150,000 higher in the first year than this value-based pricing model. So even though in year one, the net impact of the embedded analytics implementation was a loss of around $32,000, that's merely because there was implementation in year one. That would have been a much higher, higher net impact, we'll say, if they had used a traditional pricing model. So, but you can see, by the time they started in year two, they were already netting $500,000, and year three almost $1 million. So in this initiative, for a business that was at the time doing $10 million a year, by year three, increasing profitability by $1 million was a huge needle mover for this company. And this was all through value-based licensing, through adding an embedded analytics module that they could offer to their end user customers. And actually, this project is more of an outlier because the first year was a negative impact. So for a lot of business cases, we see projects could be cash neutral in the first year, and that's because implementation for these use cases happens very quickly. It can be as quick as 3 months, which means that a company can go to market with a live release within the first 6 months of deciding to pursue an embedded analytics strategy. So this is a really cool example. This is a template that we've built that we will distribute to everyone on this call, that you can take a look and play around with, see what the differences are between traditional versus value-based pricing. Based on your assumptions, you can change hosting costs, support costs, whatnot, and see what the net impact will be in the first 3 years. So that's to say, fourth industrial revolution is a data revolution. Businesses need to take advantage of this data and either monetize it or create a data-driven decision-making culture. And how do we really create a business case around that? We've walked through an example of that, and you can build your own based on the template we've shared. If you have any questions, we can switch to chat and take a look at the chat, but I'll switch to one last slide here about resources. So we do have this template you can see there that we'll distribute to everyone. If you're looking for more examples of work we've done in embedded analytics, we have a lot on our website, yellowfinbi.com. You can also email me directly, john.burr@yellowfin.bi. Happy to discuss anything about embedded analytics or brainstorm around what you think the fifth industrial revolution is going to look like, or talk about refrigerator recommendations, all of the above. Appreciate the time, everyone. Thank you very much, and look forward to hearing about your journey with embedded analytics. Have a nice day. Thank you.